Hello friends, good evening and welcome to my YouTube channel with my name Yugal Pachauri. As you all know that I'm a researcher at IIT Mandi. At present, I am working as a senior research fellow at IIT Mandi. I do post videos related to different content, sometimes technical and sometimes non-technical. So continuing the series, I'm posting the video on the topic related to the rectification. That is the two types of rectification, full wave and half wave rectifiers. Let's continue the series and let me share my screen with you all so that you can see the content that I'm trying to present in front of you. The content that I'm presenting is from the book that is known as the Boyle State. So I'm referring that particular book for the delivery of the content, and I'm disseminating information or the knowledge through the YouTube channel with my name Yugal Pachor. So, friends, there are two types of diode. One is the um, half wave. Uh, Two types of diode works in two mode. One is forward wise and the reverse wise. But basically, the diode is used for various types of application. One of the application is the rectification. That is the half wave rectification and the full wave rectification. Some part of the discussion that I've already done in the previous video that I have presented in front of you. Here, I'm continuing the series of the rectification. So I told you there are two types of rectifier. One is half wave rectifier, and another is a full wave. So let's first do the half wave rectification. As you can see in the figure 2.4, there is waveform. This is the AC waveform. AC means alternating current. So there is a voltage and there is a time. So the voltage is changing with respect to the time. That is, it has a frequency, and this type of signal is known as the alternating current signal or the AC signal. So when you pass the AC signal to the diode, see, this is the positive cycle and this is the negative cycle. From 0 to T by 2 is a positive cycle and T by 2 to T is the negative half cycle. So when these two cycles will pass through the diode, in the positive cycle, the diode will be forward biased, the signal will pass and you will get the output. Whereas in the negative cycle, the diode will be reverse biased and it will be act as an off switch and it will not pass the signal and you will get the output as a zero. So the waveform that you will get in the uh, first half cycle will be like this. This is the positive half cycle. Diode is on. It is with a short circuit and there is a resistance and there is a voltage across it. V naught is equals to Vi. So you're getting the output. Whereas in the negative half cycle, the diode is reverse biased and act as an off switch, which is shown in the figure 2.46. You can see this is open circuit, and you will getting the output as zero. So only the half wave is rectified. The negative wave is not rectified, and you are getting the output zero in the negative half cycle. Again, the positive cycle will come, you will get the output. Again, there is negative, you will get zero. If it is positive, then you will get the output. So it means out of the two wave, out of the positive half cycle and out of the negative half cycle, you're getting only one half cycle, that is the positive half cycle. If the polarity of the diode is reversed, then you will get the negative half cycle and the positive half cycle will be blocked and the negative half cycle will be passed. So this type of rectification is known as the half wave rectification. And as you can see, the output waveform of the half wave rectifier, you can see these are the two cycle plus, minus, positive and negative. And and you are getting only the output only in the positive half cycle, that is plus zero. So if you try to take the average of these the signal shown in the 2.47 figure, VDC is equal to 0.318 into VM, maximum voltage. So the rectification efficiency is quite less in case of the half wave rectifier, whereas the rectification efficiency is higher in case of the full wave rectifier. However, the number of diodes required in the half wave rectifier is only one, whereas in the full wave rectifier, you require more than one diode. It may be either two or it may be either four, depending upon the type of the full wave rectifier. Basically, there are two types of full wave rectifier. One is the center tape full wave rectifier, and other is a bridge rectifier. In the center tape full rectifier, you will get you will use two diodes, whereas the bridge rectifier you will use four diode. So the peak inverse voltage in both the rectification will be different. PIV is equals to 1 volt is equals to V volt V in the full wave. Peak inverse voltage is equals to 2V in the bridge rectifier. And you will understand these are the examples of the like you we have just understood the working of the half wave rectifier. So you can do these examples of the half wave rectifier by yourself. And if you have any doubt, you can post them in the comment section, and I'll be happy to answer them. So now come to the next topic, the full wave rectification. Full wave rectification is because of the bridge network. I already told you in the discussion of the video that there are two types. One is bridge and other is a center tape. The construction of the center tape rectifier is quite tough because you need a center tape transformer, and the construction of the center tape transformer is very complex in nature. That's why the construction of the center tape full wave rectifier is quite complex, because you need a transformer which is through which the center wire should be passed, and to find out the center of the transformer is a challenging task. So you can see in this particular operation, there is an input in the figure 2.53. There is an input in the positive half cycle and the negative half cycle. There is a voltage and there is a time curve. So you can see there are the two diodes. In the suppose there is a positive half cycle, plus and minus. So in the positive half cycle, D2 will be on, and you will get and D3 will be on, whereas D1 and D4 will be off. So you will get the output as a positive half cycle. This is the condition of the positive half cycle. You can take the screenshot of this to understand it more further. You can see D2 is on, this is D2, and this is D4, D3. So D2 and D3 and are on, and you are getting the output as the positive half cycle. Whereas in the negative half cycle, you can see this is minus, this is plus. You see that D1 is D1 is on and D4 is on. D1 and D4. The wave will flow like this, plus D4 is on, then you'll get this, and therefore D1 is on, and you're getting the output. So you can see with this, the diagram, the 2.57, you can see in the 2.57 that in both the half cycle, the positive half cycle and the negative half cycle, you're getting the output, uh, the DC output. It means there is no negative cycle. There is only the positive curve is there, because there is only one directional flow either in the positive cycle or in the negative cycle through the resistor R. There is only one type of flow. You're going this way only in both the cycles, whether it is positive or negative half cycle, but the directional flow is from this side, as you can see in the resistor. Yeah. So there is the current is flowing through the resistor. There is one directional flow in through the resistor from positive like this and negative like this, but they are both are same in case of the flowing of the current. They are flowing through the direction is same. That's why you're getting the output as a plus and the plus. Whereas the rectification efficiency in the full wave rectifier is quite higher than the half wave rectifier. It is VDC is equal to 0.636 voltage, maximum voltage of the AC signal. So you can see this is almost double. Earlier it was 0.31 something, now here it is 0.636 VM. So you can see the difference between the full wave rectifier and the half wave rectifier. Like I told you, there are two types of rectifier. One is full wave and the half wave, and there is a rectification efficiency different. The ripple factor is high in the half wave rectifier. The ripple factor is low in the full wave rectifier. Why? Because you are rectifying the complete signal. Whereas in the half wave rectifier, you are only rectifying the half signal. So there is a difference in the operation of the full wave rectifier and the half wave rectifier. However, on the basis of the application or the basis of the utility, you require the full wave rectifier more, because you do not want losses of the one cycle during that in the half wave rectifier, whereas you want the complete signal to get rectified. That's why you use the full wave rectifier much more. But the half wave is the concept and the full wave is the utility. So, and I told you about the center tape rectifier, center taped transformer, transformer rectifier. You can see this is the positive cycle, this is negative cycle, and you can see this is the center tape transformer that is shown in the figure 2.60. This is the center tape transformer. One is a positive, negative. This VI is split into two signals, VI1 and VI2 plus, and CT denote the center tape transformer. So when the positive half cycle is split into two parts, the D1 get forward bias, and the split into second part. Second part will get D2 in the forward bias. That's why you get the output in both the cycles, whether it is the reverse bias and the forward bias. In first case, if you apply the positive half cycle, the D1 is forward bias and D2 is reverse bias. In the second case, you apply the negative half cycle, the D1 is reverse biased and D2 is a forward bias. Reverse bias means open circuit like this, and forward bias means the short circuit like this. So you in this operation of the center tape rectifier, you can see this operation, operation number one, and this is the operation number two. In both the operation, you get the output. Hence, the output will be like you are getting the output in both the cycles. So both the cycles are rectified. The positive cycle is also rectified, and the negative cycle is also rectified. So that's why it is working as a full wave rectifier. However, I had already told you the construction of the center tape rectifier is quite complex. That's why the cost and the manufacturing of the center tape full rectifier is quite tough, and it is quite expensive also, because the construction of the center tape rectifier is quite complex in nature, and it is expensive also. So you can do some examples based on the rectification, and if you have any doubt based on these examples, you can ask me in the comment section. I'll be happy to answer these your questions. Now come to the important topics like clipper. Clipper, let me read out the definition for you. There is a definition. Let me highlight this. There is a definition. Definition says that clippers are network that employ diodes to clip up away a portion of an input signal without distorting the remaining part of the applied waveform. It means the clipper clips the waveform. So suppose if you want to remove some portion of the waveform from the particular waveform, then you need a circuit that is known as a clipper. So the clipper are of two types, series clipper and the parallel clipper. Suppose just see the circuit this. There is a diode and there is a applied voltage, there is a resistance, and you will get the output as a V naught. Vi is the input voltage and V naught is the output voltage. Whereas when you apply the voltage, this is the applied voltage Vi. This is the first half cycle, this is the second half cycle, and this is the output. You can see how it is working on. So if you apply a voltage like this, and there is a voltage across here V, and there is a diode, there is a resistance. So you will get the clipped output in terms of the waveform. So let me, now you understood what I'm trying to say, and you can do some numerical based on the clipper. The clipper clips the waveform. So there is a 20 volt is the maximum peak of this input, and there is a opposite polarity of 5 volt, and there is a diode. So in the positive half cycle, see there is a 20 volt, and there is a add-on in of 5 volt, and so you'll get the output as 25 volt. And there is because this diode working only in the uh, positive half cycle, you are getting 25 volt. However, the negative peak of the voltage get clipped, and you're getting output at 0. So it is starting from 0 to 25 volt, and in the negative cycle, you're getting the 0. So the portion is get clipped off, the negative portion get clipped off, and you're getting only the positive portion. Based on the circuit, you can do the analysis and find the output. Simply, if we, in simple, but if we try to understand what is a clipper, so clipper is a circuit. It clips the output depending upon the operation of the circuit, and the basics of the operation will remain the same. You have to apply the KVL, KCL, and the operations of the diode, whether it is short circuit or open circuit, depending upon you have to do the calculation, and you have to find out the output of the waveform output. Then you can say whether the output is clipped or not. If it is clipped, then it is working as a clipper. It means if you want to remove the portion of the output, then you want to work that particular circuit as a clipper. So again, this is parallel clipper. You can see in the previous circuit, the diode is placed here. Now here the diode is placed in parallel. So this is a parallel clipper. Again, the operations remain the same, and you can do the analysis to find the output of the um, clipper in the parallel connection. After that, there is one more circuit that I will tell you, and you can do some examples. These are the some of the combinations of the clipper, positive clipper, biased clipper, simple parallel clipper, ideal diodes, biased parallel clipper, simple parallel clipper. So there are different types of clipper that you can do the questions or numericals from this particular book. That is the Boyle State, which is a very standard book for the students of electronics, who are the subjects of applied electronics, basic electronics, or the application of electronics. Now there is one more type of the circuit, that is a clamper. Clamper. Now let me highlight the definition of the clamper. This is the definition of the clamper. Yeah. It says that clamper is a network constructed of a diode, a resistor, and a capacitor that shifts a waveform to a different DC level without changing the appearance of the applied signal. So, in the case of the clamper, there is one more addition of a component that is known as the capacitor. However, in the clipper, there is no uh, availability of the capacitor, but in clamper you will in the capacitor. Clipper clips the circuit, clamper clamps the waveform. Clamps means you will hang a waveform from one voltage level to the different voltage level. That is called clamping. So you have a capacitor in case of a clamper. That's why it works as a clamper. So you can see there is an input. Vi is the input. V naught is the output. And you can see there is a diode, there is a resistance, there is a capacitor. So the capacitor will get charged in the one of the cycle, and in other cycle it will get discharged. So you will get the output in both the cycle. That's why the waveform gets shifted from one voltage level to the another voltage level, and in English we call it as clamping. So you can see the operation like this is the voltage. The capacitor is getting charges towards the V, and the diode is forwards. And when there is negative cycle, the diode will be off, and you will get the output from the capacitor. So in both the cases, you will get the output like this. There is a voltage, and the capacitor got charged, and in negative cycle, you're getting the voltage from the capacitor also, and from the source also. That's why you're getting the output as 2V. Whereas the applied voltage was only V, and you're getting the output as 2V here. So you can understand the operation of the diode. And if the polarity got reversed, then you will get the output with the opposite polarity. So these are the basics. The operation of the circuit is not tough. Like I'm giving you lecture on the clamper. However, if you do the calculation with the pen and paper, you can easily understood the operations of the clamper. But you need to understand the basics of the capacitor. That capacitor get charged in first cycle, it get discharged in the other cycle, and the diode get forward biased in one cycle, and other cycle it get reverse biased. And if there is a battery placed, then you have to apply the KVL to understand the calculation of the battery and the input voltage. So by that concept, you can understand how the waveform is clamping from one voltage level to the other voltage level. So these are the two important circuits that are acting as the application of the diode. One is the clipper, other is the clamper. And the previous part of the video, I already told you the rectifier. There are two types of rectifier. One is the half wave rectifier, and other is the full wave rectifier. So with this, you can understand what I'm trying to say, and you can do some numericals or the examples. And if you have any doubt, you can ask me in the comment section, and I will be really happy to answer all your questions in the query. But if your basics are strong, if your fundamentals are strong, you can easily solve these circuits. These are not very tough to understand. Initially, they are tough, but if you try to solve them judiciously, you are able to solve these circuits very fundamentally. So I think Now there is one more topic: network with DC and AC source. So, like suppose you can operate these diodes with the two types of sources. One is the AC source and the DC source. Depending upon them, there are the application. The DC source application are different. The AC source application are different. So you have AC resistance, you have the DC resistance, and you have the AC capacitance to the DC and through the AC. And this thing is already been discussed in the previous part of the my lecture series, and you can find the previous series in the playlist as well. So this is the now xenodiode I've already discussed. Xenodiode will act as application. It is acting as a voltage regulator. Now coming on to the next topic. This is something which can be done. You can solve this. Uh, Fixed variable resistance. You can see this. I'm just scrolling. So yes. So I think this voltage multiplier circuit I will do in the next part of the video. So I think I'm stopping over here so that you get idea about the rectifier, that is a full wave, and the half wave rectifier. Full wave are of two types. One is the center tape, another is the bridge rectifier. And we discussed about the clipper. Clipper are of four types: series clipper, series parallel series. Clamper are two types: series clamper, parallel clamper, and the parallel series and a series parallel, and the ideal and the biased clamper. So you can understood the content of this video that I have delivered through the YouTube. You can try to understand. And if you have any comments or suggestions, I'll be happy to answer all your questions and happy to accept all your suggestions through the comment section. And I think that's it for this video. Now we will meet in the next part of the video in this playlist. So thanks for watching. Have a nice time.